right, thank you everyone for joining. You are in Tech Lab's webinar today to talk about securing your CTV ad spend with OM SDK's device attestation. I'm Jill Whitcap, VP of Product. I will talk just for a few minutes about what Open Measurement is, OM SDK, and what its overall deal is. And then I will turn over the floor to Vinod Panikkar, who's Principal Product Manager at Amazon Ads, and he'll talk through the feature that we released in November of 2025, so just end of last year, device attestation. If you guys have any questions as we're going along, feel free to put them in the question box, and we will have some time at the end for answering any of those questions. So feel free to drop them in as we go. So I always like to start with this because I think that it's really important to point out that the industry keeps on telling us that measurement is the top challenge in activating CTV programmatically. This is from the 2025 IAB Digital Video Ad Spend and Strategy Report, which goes sort of in depth on all of the challenges, opportunities, how people are thinking about their campaigns when it comes to CTV and programmatic and video ad spend in general. And so measurement complexity continues to be sort of a top challenge in that activation process. And then the most important data to get from ad sellers for measurement are those campaign and placement level KPIs. And I think that that really highlights the measurement complexity from fragmentation and cross-channel consistency, that those are still areas that the industry is asking us to address. And we hear that constantly in just the conversations that we're having in market. And so what are some of those questions that buyers ask about CTV measurement? We have a handful of the questions on screen. You get a lot along the lines of like, was my ad actually seen? Was there a real person watching my ad? How can I be sure that platform A and platform B are measuring consistently? Based on some experiences, the question of like, was the CTV device on? So if you have sort of an external stick device or something where you have a question of if there's a difference between what you're seeing on the screen and what is happening with the technology or the operating system. And is it a real CTV device? We really just have a lot of questions when you're making those CTV purchases that we want to make sure are addressed in a consistent way. And in case, I think most folks are familiar with why buyers are asking for this third-party verification on impressions, just to make sure, like, to have that source of trust and consistency. But in case folks need a reminder, they use this data to optimize their campaigns, to allocate budget on an ongoing basis, to really connect the impression, the exposure event to the outcomes that they're measuring, and to track that cross-channel or cross-device journey for users. And all of that is critical on the advertiser side. And so what we really want to think about with open measurement is making sure that we provide that consistency in the exposure event, in the impression event, and make sure that there is a set of consistent signals that are expected and utilized to really start off this process for the advertisers. And how does OM SDK help with that? Well, Open Measurement, standardizes the measurement signals for video across platforms. So you can see here that we have support we started in mobile back in 2018. So for iOS and Android devices, we provide support. We did web video in 2020. And over the last few years, we've been adding to the catalog of CTV operating systems that we provide that level of support for. So you can see tvOS, Android TV, which includes Fire TV, Samsung, and LG. And some of those, again, like from the questions that buyers are asking, a lot of those are very unique CTV challenges. They are specific to the experience of a consumer watching ads, watching content on their television device. And to highlight some of those, they also have their own measurement requirements. So from the MRC, from a measurement accreditation process, there are questions that we want to make sure are answered. And those go back to is anyone watching, which boils down to like, do we have any recent signal or understanding that there was an interaction with the content. Is the TV screen on? So when there's a potential disconnect between that, the TV display could be off. We want to have as much assurance in what's happening there as we can. And the one that we will dig into more today is that device attestation. So, what is this device saying it is, and how can I think about verification of that? And these, I mean, these are problems or challenges no matter what device you're on, but I would say that with CTV, they definitely with the investment of the large scale formats, you really want to double down on making sure that those challenges are addressed, and that's how OM SDK helps. It standardizes that sort of baseline understanding of impression and viewability measurement. So what you can expect, what you should expect from your partners when you're getting just the base level of signals of what happened with your ad on the expected device. The added bonus of the security, safety, and fraud prevention, making sure that we have the ability for invalid traffic detection. And then giving and all of those things sort of moving into the fact that that gives the advertisers the information that they need to be able to make the decisions to optimize their campaigns with confidence. And so OM SDK is it's actually an SDK that's provided to the industry. The group in the middle are the industry leaders that are invested in actively developing this code. So all of those folks help on a regular basis with support and integration support and feature development for the SDKs and keep us moving in the right direction. And that's how we got to what we'll continue to talk about today, which is the device attestation feature, which is something that we really, the commit group really felt was necessary in adding to sort of that suite of solutions to make sure that we were providing the best standardization possible for measurement in the CTV ecosystem. And I will pause there and turn over to Vinod to pick up and talk about device attestation in more detail.
Thanks, Jill. Hey, everyone. Let me just start sharing my screen. All right. So, my name is Vinod Panikar. I'm a principal product manager at Amazon Ads, working in the supply quality space for over 11 years now. I lead the supply quality standards program and collaborate with industry bodies on standards pertaining to supply quality. So today, I'm going to talk about the pervasive device spoofing problem and the solution that we standardized as part of the Open Measurement SDK. But let's first start by understanding what device spoofing is. So bid requests and measurement beacons communicate information about the device on which the ad is intended to be shown. This information represented in the user agent or UA string is used for various purposes, including ad selection and measurement. But as you can see in these examples on the slide, the device information is communicated as a text string that can be easily manipulated. A bad actor can change the text to make a low-value device into a high-value device, such as a CTV device. And if you check any scaled ad fraud operation or sophisticated bot, it's likely that you will find that it's leveraging device spoofing as an underlying technique to evade detection. Now, device spoofing is invalid traffic, or IVT, and it affects publishers and advertisers alike. Let's take a moment to understand why that is so. Ad spend on spoof traffic is a waste because spoof traffic is IVT. So the impact on advertisers is reduced return on investment. But on publishers, the impact is less apparent. Since ad budgets are capped, winning ad spend becomes a zero-sum game for publishers. When bad actors steal away ad spend, there's less to go around for legitimate publishers. Effectively, that means reduced monetization for legitimate publishers. Assuming that a percentage of an advertiser's ad budget is spent on spoofed supply, that's wasted ad spend for the advertiser, but it's also ad spend that could have gone to legitimate publishers instead. That is why all advertisers and publishers should care about solving for ad fraud and IVT in general, regardless of where it's taking place in the industry. You may have heard of domain spoofing and app spoofing and the industry standards such as ads.txt and appads.txt that help solve for them. But ads.txt and appads.txt are still reliant on good intentions of parties in the supply chain. What do I mean by that? A reseller could theoretically use tactics like bid duplication or purchase traffic to drive incremental revenue to themselves and to the publisher. This also helps publishers win at the zero-sum game. After all, publishers are competing for the same ad dollars. So while ads.txt and appads.txt are useful and important in driving down domain and app spoofing, they cannot and were not designed to solve for device spoofing, which remains a persistent threat even when these standards are adopted. To reiterate, when spoof traffic is monetized, both advertisers and legitimate publishers stand to lose. That makes it a shared problem, and standards-based approaches are the best way to solve for such shared problems. Privacy Pass is a new protocol standardized by the IETF, the Internet Standards Body responsible for protocols like HTTP. The device attestation mechanism is built on top of Privacy Pass, which is itself built on top of the HTTP protocol. Privacy Pass can be used for device attestation in an ads context. Privacy Pass enabled clients can assert a property about themselves without revealing any identifiable information, which makes this solution privacy preserving. In other words, a Privacy Pass client operating within an app can demonstrate that the underlying device on which the ad is served is authentic without providing private information. In addition to strong privacy properties, this Privacy Pass-based mechanism also offers strong security thanks to its compartmentalized architecture and its use of cryptographic tokens. Since these tokens utilize a challenge response cryptographic mechanism, the response necessarily incorporates the challenge within it, making it hard to generate fake tokens because the challenge keeps changing over time. Now let's take a look at how this mechanism would operate for digital ads. This mechanism utilizes the most secure and privacy-preserving deployment model in the Privacy Pass specification and contextualizes that to the ads verification use case. This verification flow operates purely in the measurement context, so there are no changes to the pre-bid flow. This has the added advantage of fitting well into the independent verification model many advertisers rely on today. This mechanism depends on two new entities in addition to the existing entities: the client or app on which the impressions are being served, and a measurement or verification provider. The two new entities are the device manufacturer, which acts as an attester, and a Privacy Pass token issuer. This token issuer can be an existing Privacy Pass token issuer, such as AWS Web Application Firewall, or Cloudflare, or even Fastly. The measurement or verification provider can choose to host a token issuer by themselves as well. There are trust relationships and boundaries between these entities that protect privacy while providing security. The Privacy Pass client runs in an app on the device and trusts the attester hosted by the device manufacturer. The verifier can be a measurement or verification provider. The verifier expects the client to prove its authenticity by getting a Privacy Pass token from a trusted token issuer. And the token issuer trusts the attester, having established that the attester only attests to genuine clients. The verifier, attester, and issuer are all cloud services. Jill already spoke about the Open Measurement SDK, and it's an independent measurement SDK that was launched in 2017, and it's the industry standard for impression and viewability measurement. And it has broad coverage across mobile apps. The coverage is around 95% of mobile app impressions from what we understand. But support for CTV is still growing, as it was fairly new as compared to the mobile app SDK. And it's supported by the Open Measurement Commit Group, which contributes to its development. Now, if you look at the attestation flow itself, when the ad with the verified URL is delivered to the app, the Privacy Pass client makes a call to the URL to advertise its capability. If the verifier wants, it can challenge the client to produce a token from a trusted issuer. The client reaches out to the attester and requests it to fetch a token from the issuer on its behalf. The attester first verifies that the client is genuine before reaching out to the issuer. And since the token request to the issuer comes from a trusted attester, the issuer mints the token and returns it. The attester passes the token back to the client, which then presents it to the verifier for verification. The verifier verifies that the token is valid using the issuer's public key and increments counters at its end against various supply-side dimensions, which will help paint a picture of device authenticity rates behind individual sellers over time. So the signals that are derived from this mechanism are intended to be interpreted at the seller level. You can think of a seller as any entity that is in the flow of money, an entity getting paid by the advertiser's dollars. The supply chain object holds seller data, and the signals, when aggregated at various seller level dimensions, such as seller ID, seller domain, ASI, etc., can provide interesting insights. New metrics have been defined that help interpret the signals, enabling different entities in the industry to share information about the seller entities that run afoul of the metrics. And when metrics appear anomalous for certain sellers, verifiers can dive deep and determine the right enforcement action to take on the seller. It could be a decision to add the seller to a block list, or to reduce the bid rate when the seller appears in the supply chain, or even to bid differentially. This is how the standardized solution would look like, again, with examples for the different entities. Now, the mechanism, the privacy pass-based mechanism today is available for Fire TV and Apple TV and other devices, other Apple devices as well. Other manufacturers can also end up supporting privacy pass. The app, when integrated with the OM SDK that has support for device attestation, will talk to an on-device privacy pass capability. And this on-device privacy pass capability, supported by the operating system, is what communicates with the device attester and the privacy pass token issuer by extension. And the tokens can flow from the app back to the verifier for verification purposes. So this is just the same diagram, but laid out differently. Now let's take a look at how a spoofed request would actually appear. So this is the terminal app running on a Mac device, and I'm going to simulate a measurement event. Now, there's a simple HTTP request to the highlighted origin, and that's basically the verifier URL that you can see over here. So this is the user agent string that's highlighted, and the user agent string is actually representative of a Fire TV device. This window at the bottom is Charles proxy, which allows us to intercept requests that are in transit. And as you can see over here, there was a request made to the verifier, and the verifier responded with a private token challenge. Now, since this is just a simulated example running in the terminal app, it is not able to produce a privacy pass token in response. And that is what is expected in this case. But if you look at a real example of the open measurement test app that's running on a Fire TV device, with Charles proxy intercepting the request in transit again, we see that the request was made by the app, and the verifier responded with a private token challenge, as you can see on screen. Now, this challenge needs a response. So the underlying app is actually getting a token from the attester, which gets it from the issuer, and it's presented to the verifier for verification. And the same mechanism works as expected for Apple devices as well. So we've got the OM SDK test app for Apple, and we've got Charles proxy helping us intercept the requests and responses again. And as the ad loads, there is a request that's made to the verifier. The verifier responds with a challenge, and the underlying privacy pass-based mechanism gets a token from the attester and presents it to the verifier for verification purposes. So all of this is happening in the background without any user interaction whatsoever. And this is also taking place in a sampled manner. So it's not like there is undue burden on the device to request and respond to all of these challenges and tokens that are expected. So it's done in a way that's actually very conscious of device performance. So playback experience, especially in case of these devices, is very, very important. So the way this is designed, there's hardly any resource utilization burden on the client device or on the user device. So this capability is launched in OM SDK. As Jill mentioned, we launched this in November last year. And the implementation guide is also available on the IAB Tech Lab website. There's a URL on screen. And verifiers can implement this. What we need is for publishers to adopt this by either integrating with Open Measurement SDK or by implementing this directly. And we've got a couple of devices or device manufacturers supporting Privacy Pass already with Fire TV and Apple devices on board today. Measurement providers have been collaborating through the IAB Tech Lab Open Measurement Commit Group to implement support for this. So that's also something that's happening in the background. Publishers, as I said, need to integrate with either OM SDK 1.6 or integrate with an ad SDK that's already integrated with OM SDK 1.6. And the capability will get activated automatically without the publisher having to do anything. So no code has to be written to support this capability. And all of this is activated in the background with the metrics actually flowing, and we will start being able to figure out who are the sellers that are actually mixing fake inventory or spoofed inventory with real inventory, or just like it being all spoofed inventory altogether. And if advertisers and agencies start asking for this, then we can accelerate adoption as well. So that was it from my side. And Jill, back to you.
Thank you, Vinod. I will give one more call. That's what we wanted to cover today. We thank everybody for their time and listening. One more call for any Q&A. I do not see anything in the Q&A box, but I will stall for you for 30 more seconds if anyone wants to get in any question. All right. Well, thank you everyone for your time. Thank you, Vinod, for your expertise. And we look forward to any questions you guys want to send. Feel free to send to Jill at iabtechlab.com. And we're happy to talk in depth more about open measurement and what it takes to integrate. Thank you.
Thanks, Jill. Thanks, folks.